Hello students, welcome to this session. In our previous session, we have discussed Fourier transform and Fourier cosine transform and Fourier sine transform, and we solved some examples on Fourier transform. In this session, we are going to solve some more examples on Fourier transform. Now, working method is same, and Fourier formula of Fourier transforms, whatever we have discussed, we are going to use those formulae again. So here this f of s is Fourier transform and fx is inverse Fourier transform. We are going to use these two formulae in solving examples. Now we have already discussed this working method. So if function is provided and it is asked to find Fourier transform, then we have to use this formula to find Fourier transform. So after getting Fourier transform, to evaluate any integral which is asked, we have to use this formula of inverse Fourier transform. Now, among these examples, we have solved first two examples in our previous session. Now, let us solve this third question. Now, let us see this third question. Third question is, find Fourier transform. Find Fourier transform of fx equal to a square minus x square a square fx equal to a square minus x square mod x is less than or equal to a and 0 when mod x is greater than a. Mod x is greater than a. Here this is if mod x is less than a, here mod x is greater than a, which is greater than 0. This is given question. Now, one more sub question is there, hence evaluate integral 0 to infinity sin x minus x into cos x upon x cube dx equal to pi by 4. So, let us solve this question. To solve this question, first we have to identify given function and we have to identify the transform which is asked. Then we use formula of the transform. So here fx equal to a square minus x square. Here mod x is less than a. So we can write this condition as minus a less than x less than a. And 0 for mod x is greater than a, we can write this condition as minus infinity less than x less than minus a and a is less than x less than infinity. Now, here it is asked to find Fourier transform. So, here Fourier transform, formula of Fourier transform is fs equal to f of fx, which is equal to integral minus infinity to infinity f of x e power isx dx. This is formula of Fourier transform. Now using this Fourier transform, we have to solve this question and using this given function. Now this integral can be written as integral minus infinity to minus a, because here first one is minus a to a. This is minus infinity to minus a and a to infinity. So there are three different types of intervals. So we write this integral from minus infinity to minus a, then in between minus a to a plus a to infinity. So we can split this interval minus infinity to infinity into three intervals. So minus infinity to minus a fx into e power isx dx plus integral minus a to a fx into e power is x dx plus integral a to infinity fx e power is x dx. Fx e power is x dx. Now in the interval minus infinity to minus a function is 0. So first integral becomes 0. In the second integral, function is means in the limits, in between the limits minus a to a, value of the function is a square minus x square into e power is x dx plus again in the third interval a to infinity, value of the function is 0. So here third integral becomes 0. So we have to evaluate this integral minus a to a square minus x square into e power is x dx. So to evaluate this integral, we use integral uv rule. Integral uv equal to uv dash minus u1 v double dash plus u2 v triple dash minus so on. So here what is u, what is v? So here the function or the term whose derivatives are means after certain operations, means after finding first derivative, second derivative or third derivative, if that derivative becomes 0, then such type of function we consider as u. Okay, that means here if you consider x cube, here first derivative is 3x square, second derivative is 6x, third derivative 6, fourth derivative is 0. So such type of finite terms, the terms which is having finite number of derivatives can be considered as u. And other term which has continuous derivatives, means if you differentiate infinite times or n times, you will get derivatives. So such type of functions we consider as v. So here among these, this is finite term, that means you get only 2 or 3 derivatives to this term. Here this is exponential term, here we get derivatives till we continue the process, right? So if you go on differentiating e power is x, you will get some derivative. So we consider this term as v, this term as u. So here a square minus x square is u and v equal to e power is x. So first derivative u1 equal to 0 minus 2x, second derivative u2 equal to minus 2, third derivative is 0, u3 is 0. Here if you consider v dash means integration of e power is x upon is, v double dash equal to e power is x upon I square s square, which is equal to e power is x upon minus s square, because value of I square is minus 1, v triple dash equal to e power is x upon I cube s cube, which is equal to e power is x upon minus I into s cube. Okay, so we use these derivatives and integrals to integrate. In integrating this one, which one? Integral minus infinity to infinity a square minus x square into integral minus a to a square minus x square e power is x dx. This can be integrated as using this formula. Here u means a square minus x square into v dash means e power is x upon is minus derivative of this minus 2x into e power is x upon v double dash is minus s square plus derivative of minus 2x, that is minus 2, u2 is minus 2, and here v triple dash means e power is x upon minus is cube under the limits minus a to a, because here to get next term we should find derivative of u2, that is u3. So next derivative is 0. So here we don't get next term, that will be 0. Now let us simplify this. A square minus x square into e power is x upon is. Here 3 negative signs, so minus 2x into e power is x upon s square. Here plus 2 into e power is x upon I into s cube under the limits minus a to a. So if you put x equal to a, first we apply upper limit. So here a square minus a square into e power is a upon is minus 2a e power is a upon s square plus 2 into e power is a upon is cube. Now if you apply lower limit, so directly we can write these terms by changing their sign. Here minus of a square minus a square e power minus is a upon is. Here plus 2 into minus a e power minus is a upon s square. So here minus 2 into e power minus is a upon I into s cube. Right? So here this term becomes 0 and this one becomes 0. Then remaining terms, that is minus 2a, which is equal to minus 2a e power is a upon is, first term. Next term is this one, plus 2 into e power is a by I into s cube, plus 2 into e power is a upon I into s cube. Here this one not is, no, s square. So first term is minus 2a into e power is a upon s square. Second one is plus 2 into e power is a upon I into s cube, this one and this one. Then third term is this one, minus 2a e power minus is a minus 2a e power minus is a upon s square. Then fourth term is minus 2 into e power minus is a upon I into s cube. So if you take minus 2a by s square common, you get e power is a plus e power minus is a. If you take 2 by s cube common, you get e power is a minus e power minus is a. Okay. Now let us multiply and divide by 2. So minus 4a by s square e power is a plus e power minus is a upon 2 plus 4 by s cube. Here upon I is there. Then e power is a minus e power minus is a upon 2i. Because among these terms we have taken 2 by s cube outside. So I remains. So here I comes in the denominator. Now this is nothing but minus 4a upon s square cos sa plus 4 by s cube sin sa. Now if you take minus 4 by s cube outside, here take this common term according to given solution. That means here what is asked, we have to evaluate this integral, right? Sin x minus x cos x. So here take minus 4a upon s cube common. Then what do you get here? Here s cos sa minus a sin sa. Now to get the value of the integral, here to evaluate integral 0 to infinity sin x minus x cos x upon x cube dx. Consider inverse Fourier transform. Consider inverse Fourier transform fx equal to 1 by 2 pi integral minus infinity to infinity f of s e power minus is x ds. Now 1 by 2 pi integral minus infinity to infinity, we know f of s, whatever we have obtained now, that is minus 4a by s cube minus 4a upon s cube s cos sa minus a sin sa s cos sa minus a sin sa into e power minus isx ds, which is equal to, here this one you can cancel, so minus 2a by pi integral minus infinity to infinity, here s cos sa upon s cube e power minus is minus a sin sa upon s cube into cos sx minus I sin sx ds, which is equal to minus 2a by pi integral minus infinity to infinity s cos sa minus a sin sa upon s cube into cos sx ds minus integral minus infinity to infinity s cos sa minus a sin sa upon s cube into I is there, I sin sx ds. Okay, but sin sx is odd function, cos sx is even function, so this integral becomes 0. Okay, so here cos sx is even and sin sx is odd. Therefore, which is equal to, this is equal to minus 2a by pi into 2 integral 0 to infinity s cos sa minus a sin sa upon s cube into cos sx ds, cos sx ds. Then next one is 0, because sin sx is odd function, that integral becomes 0, which is equal to minus 4a upon pi integral 0 to infinity s cos sa minus a sin sa upon s cube into cos sx ds. What is this? Fx. Now let us put x equal to 0. Then f of 0 equal to minus 4a upon pi integral 0 to infinity s cos sa minus a sin sa upon s cube into cos 0 ds. So here we have to find value of f of 0 and value of cos 0 is 1, and here fx equal to a square minus x square when mod x is less than a, right? Here this is 0 to, here we have to find f of 0. Here f of 0 lies between minus a and plus a. So here f of 0 equal to a square minus 0 square, which is equal to a square. Okay, so here a square equal to minus 4a by pi integral 0 to infinity s cos sa minus a sin sa upon s cube. So here a is greater than 0, so we can consider a equal to 1. So 1 equal to minus 4 by pi integral 0 to infinity s cos s minus here ds minus sin s upon s cube ds. Here cos 0 is 1, so I have written only ds. Then we get integral 0 to infinity s cos s minus sin s upon s cube ds equal to minus of pi by 4 minus of pi by 4. Okay, so this is value of the, if you take minus sign common on left hand side, minus integral 0 to infinity sin s minus s cos s upon s cube ds equal to minus pi by 4, right? So these terms, they become positive. Then if f is taken as x, you get integral 0 to infinity sin x minus x cos x upon x cube dx equal to pi by 4, which is required solution. Now let us see fourth question. So here in this solution, first we have considered Fourier transform, then we evaluated Fourier integral f of s. After getting f of s, we have used inverse Fourier transform to evaluate value of the integral. Okay, now next question is find Fourier transform of fx equal to a minus mod x when mod x is less than a, and 0 when mod x is greater than a. Also show that integral 0 to infinity sin square t by t square dt equal to pi by 2. So here first we have to find Fourier transform for this given function. Then we evaluate this integral using formula of inverse Fourier transform. Now first let us write this given function. Given function is fx equal to a minus mod x, fx equal to a minus mod x when mod x is less than a, 0 when mod x is greater than a. This can be written as a minus mod x when minus a is less than x is less than a, then 0 for minus infinity less than x less than minus a, and a is less than x less than infinity. So in both these intervals this function is 0. Okay, now formula of Fourier transform is we know that we are using fs equal to f of fx equal to integral minus infinity to infinity f of x into e power is x dx. This is formula of Fourier transform. So using this transform, we can find Fourier transform of this particular function. So integral minus infinity, this integral can be written as minus infinity to minus a fx into e power is x dx plus integral minus a to a fx e power is x dx plus integral a to infinity fx e power is x dx. So here in the interval minus infinity to minus a, function is 0. In the interval minus a to a, function is a minus mod x into e power is x dx. Again in the interval a to infinity, function is 0. So here we have to evaluate this integral minus a to a minus mod x into e power is x dx. Now here to evaluate this, we use integral uv rule as usual. So here, before applying uv rule, here a minus mod x into here e power is x, we write this e power is x first. We simplify this integrand, that is a minus mod x into here cos s x plus I sin s x dx. Okay, then we can write this integral as integral minus a to a minus mod x into cos s x dx plus integral minus a to a minus mod x into sin s x dx. Here cos s x is even function and sin s x is odd function. That means here this one is even function, this one is odd function. So we can write this as 2 integral 0 to a minus, here x is greater than 0. So we can write, so this one a minus mod x as a minus x. So let us write that in next step. Cos s x dx plus value of this integral is 0. That is 2 integral 0 to a minus x into cos s x dx. X is greater than 0. Now we evaluate this integral using uv rule. So here 2 into here u equal to a minus x and u1 equal to minus 1, u2 is 0. Now v equal to cos s x, cos s into x, v dash equal to plus sin s x, integration of cos is sin s x upon s, v double dash equal to minus cos s x upon s square, like that. So integral uv rule is integral uv equal to uv dash minus u1 v double dash plus u2 v triple dash minus so on. So if you apply this rule here, you get 2 into a minus x into integration of cos, that is sin s x upon s, minus of minus 1 into here minus cos s x upon s square under the limits 0 to a. So here 2 into, if you put, let us simplify this before applying these limits, a minus x into sin s x upon s minus cos s x upon s square under the limits 0 to a. So which is equal to 2 into a minus a sin s a upon s minus cos s a upon s square, here minus a into sin 0 upon s plus cos 0 upon s square. Now first term becomes 0, this term becomes 0, and even this term becomes 0. So we get these two terms. Cos 0 is 1. So here 2 into, which is equal to 2 into 1 by s square minus 1 by s square minus cos sa by s square, minus cos sa upon s square, which is equal to 2 into 1 minus cos sa upon s square. This is f of s, Fourier transform. Even you can simplify this, which is equal to 2 into 1 minus cos sa can be written as 2 sin square sa by 2, because 1 minus cos theta equal to 2 sin square theta by 2. So using this trigonometric identity, we can write it as 2 sin square sa by 2 upon s square, which gives 4 sin square as by 2 or sa by 2, sa by 2 upon s square. Now to evaluate the integral, let us consider for inverse Fourier transform. Consider fx equal to 1 by 2 pi integral minus infinity to infinity f of s e power minus is x ds. That is 1 by 2 pi integral minus infinity to infinity 4 sin square sa by 2 upon s square into e power minus is x ds. Now let us convert that exponential term into cos and sine. So here 4 sin square sa by 2 by s square e power is x can be written as cos sx minus I sin sx ds. So again we can write it as, which is equal to 1 by 2 pi integral minus infinity to infinity 4 sin square sa by 2 upon s square into cos sx ds minus, because first we applied this integral to first term, product of the sine square and cos sx, minus I into integral minus infinity to infinity 4 sin square sa by 2 upon s square into sin sx ds, sin sx ds. Now this one is odd function, this one is even function, this one is even. So we get 1 by 2 pi 2 integral 0 to infinity 4 sin square sa by 2 upon s square cos sx ds. Here value of this second integral is 0 because that function is odd function. What is this? This is f of x. Now here let us put x equal to 0 on both sides. Then we get f of 0 equal to, put x equal to 0. So f of 0 equal to 1 by pi integral 0 to infinity 4 sin square sa by 2 upon s square into cos 0 ds. Cos 0 is 1, and here what is fx? Fx equal to a minus mod x in the interval minus a to a. So here f of 0 is nothing but a minus mod 0, that is a. So here a equal to 1 by pi integral 0 to infinity 4 sin square sa by 2 upon s square ds. Okay, so let us simplify this integral. Here let sa by 2 equal to t, then ds equal to 2 by a dt, because implies s equal to 2t by a. Okay, then if you convert limits, when s equal to 0, when s equal to 0 implies t equal to 0, s equal to infinity implies t equal to infinity. So here a equal to 1 by pi integral 0 to infinity 1 by pi integral 0 to infinity here 4 sin square t by, because here we have taken SA by 2 as t, right? S equal to 2t by a. S square means 2t by a whole square. 4t square by a square implies s square equal to 4t square upon a square. Okay, so here 4t square upon a square into ds. ds means 2 by a dt into 2 by a dt. So which is equal to, here 4 you can cancel, here a square by pi, a equal to integral 0 to infinity sin square t by t square, here into 2 by a dt. So here a these will get cancelled, 1 equal to 2 by pi integral 0 to infinity sin square t by t square dt, sin square t by t square dt. That means here integral 0 to infinity sin square t by t square dt equal to pi by 2. Integral 0 to infinity sin square t by t square dt equal to pi by 2. Now let us see next question. Here fifth question. Find Fourier transform of fx equal to e power minus x square by 2. So here no need to find value of any integral because it is not there in this question. Only we have to find Fourier transform. So here given function is fx equal to e power minus x square by 2. The Fourier transform is fs equal to f of fx equal to integral minus infinity to infinity fx into e power isx dx. So which is equal to integral minus infinity to infinity fx is e power minus x square by 2 into e power isx dx, that is integral minus infinity to infinity e power minus x square by 2 plus isx dx, that is integral minus infinity to infinity. If you take 1 by 2 common, then you get minus 1 by 2 common, x square minus 2 isx e power minus 1 by 2 into x square minus 2 isx dx, that is integral minus infinity to infinity e power minus 1 by 2 into x square minus 2 isx. Here add and subtract I square s square. So here plus I square s square minus I square s square dx. To get a perfect square, here we make this adjustment. Okay. Now these three terms together gives a perfect square. Here a square minus 2ab plus b square. Right. So we can write it as, which is equal to integral minus infinity to infinity e power minus 1 by 2 into x minus is whole square Here minus I square s square. Minus I square s square dx, which is equal to integral minus infinity to infinity e power minus 1 by 2 into x minus is whole square plus 1 by 2 into I square s square dx. That is integral minus infinity to infinity e power minus of 1 by root 2 into x minus is whole square into e power I square s square by 2 dx, which is equal to e power minus s square by 2. Here this one I square equal to minus 1. Okay, so you get minus I square s square means minus s square. So I square s square is minus s square. So this minus s square can be written outside. Integral minus infinity to infinity, because integration is with respect to x. So s square term can be right outside. So here e power minus of x minus is by root 2 whole square dx. Right? Now, to simplify this integral, let us consider x minus is by root 2 equal to some t. Then dx, here x minus is equal to root 2 into t, dx equal to root 2 dt. When x equal to minus infinity, t equal to minus infinity. When x equal to plus infinity, t equal to plus infinity. So, e power minus s square upon 2 integral minus infinity to infinity e power minus t square into root 2 dt. Right? Now, which is equal to root 2 into e power minus s square by 2 integral minus infinity to infinity e power minus t square dt. Here this one is even function, so we can write it as 2 root 2 e power minus s square by 2 integral 0 to infinity e power minus t square dt. Now here this one, again using gamma functions we can evaluate this. Here let t square equal to some k, t square equal to k. Then 2t dt equal to dk, 2t dt equal to dk, dt equal to dk upon 2t, that is dk by 2 root k, because implies t square equal to k, t equal to square root of k. Right? Now, when t equal to 0, k equal to 0. When t equal to infinity, k equal to infinity. So here we get 2 root 2 e power minus s square by 2 integral 0 to infinity e power minus k and dk by 2 root k. That means here this 2 and 2 will get cancelled. You get root 2 e power minus s square by 2 integral 0 to infinity e power minus k. If you take this root k in the numerator, k power minus 1 by 2 dk. That is root 2 into e power minus s square by 2 integral 0 to infinity e power minus k, k power 1 by 2 minus 1 dk. That is root 2 e power minus s square by 2. Here this is nothing but gamma 1 by 2. Since integral 0 to infinity e power minus x power n minus 1 dx equal to gamma n. Okay, according to definition of this gamma function, this is gamma half. Value of gamma half is root pi. So we get root 2 pi into e power minus s square upon 2. This is Fourier transform of fx. that is e power minus x square by 2. So this is f of s. F of s equal to root 2 pi into e power minus s square upon 2. So thank you. In this session and in our previous session, we have discussed examples on Fourier transform. In the next session, let us see examples on Fourier cosine transform. So let us meet in next session.